Olá, seja muito bem-vindo ao 3D Talk, o programa que traz as principais tendências e aplicações da impressão 3D nos mais diversos segmentos industriais. Meu nome é Bruno Oliveira e hoje a gente tem um programa muito especial. Eu tenho aqui comigo o time da BASF Forward AM, a parte responsável por impressão 3D, materiais por impressão 3D da BASF, e o pessoal que está aqui comigo veio direto da unidade dos Estados Unidos para visitar ao longo dessa semana a FEIMEC e, claro, conversar um pouco sobre algumas parcerias que tem entre a Aditiva, BASF 3D para o desenvolvimento do mercado de impressão 3D. Eu tenho aqui o Todd McKinley, Jaime Zapata e o Mark Goethe. Eu vou pedir para que eles se apresentem um pouco. Hoje o programa vai ser discutido em inglês com eles, mas é muito importante ter a BASF presente aqui porque mostra que as empresas estão realmente olhando para esse mercado brasileiro de impressão 3D industrial de uma maneira muito séria. Guys, thank you so much for being here and for making yourself available for this talk. It's important for the market to understand that BASF has such a big presence in 3D printing technologies, and that your guys are able to come here, see our country, our development, and everything. I'll ask you just to present yourself, what you're doing in BASF for the people that see us through TalkPlast.
So as you said, I'm Todd McAnally. I am the powder technical specialist for our team, so I handle application development topics as well as parameterization activities for different platforms. I am the head of technology as well for our technical center in Detroit, Michigan.
Okay, so you're based in Detroit and responsible for the technology that use powders for 3D printing, right?
Correct, yep.
Perfect.
My name is Mark Goethe. I'm also from Detroit, Michigan. I'm the technical specialist for our resin profile. I also do application development, parameterization, just like Todd, but for the resin side of the portfolio.
Thank you, Mark.
Thank you for having us, Bruno. My name is Jaime Zapata. I am the channel sales manager for BASF, so I oversee the distribution for the Americas. They're the brains for the business here, and I'm just here to come along, but I'm really excited to be here. I've seen a lot this week, and I think Brazil has a lot of potential for us in the market.
That's perfect. Guys, I was discussing every time that we talk here in TalkPlast to the people from the plastic industry about 3D printing, we are always presenting that 3D printing is not only the filament production, that technology that you have the plastic filament and you produce your parts, but there's also the powder technology and also the resin technology. And I would like you guys to discuss a little bit for us what are the main materials and what are the main applications with both of these technologies, because it's good for us to have the technical experts here to talk directly to us. And if you want to show, because here we have a few parts produced in all the technologies. I think we have filaments, we have parts made through resins, and also we have powders, right? So if you can explain a little about the applications, the material used in the powders and resins, please.
Sure. I'll go ahead. You've got a lot more materials. For the powders, we have PAs, like is more commonly known for the powder machines, but there's PA 12 is kind of the industry standard. We have focused more on PA 11s. So we have, it's a more ductile plastic. It has really good impact resistance, but we've also focused on trying to make engineering grades of that. So we have carbon filled version of the material. We have a static dissipated version of the material.
This one is the carbon filled. So this is a grade of PA11, carbon filled for powder 3D printing.
Correct. Yeah.
What are the main characteristics of this material?
Just like a normal carbon fill, it's going to lighten up the overall weight of the part, so you'll have a little lighter part. So it's better for like mobility, transportation type of applications. The CF will also stiffen the part up, so parts that have a more rigid requirement, the CF is going to be better for. We have polypropylene, which is a little bit more atypical for the industry. Yeah, polypropylene is a good material for us because it's kind of recognized in the more traditional manufacturing industry. So when we start talking about it, there's a better connection to the material, but it provides a lot of benefits for ductility, again, similar to a PA11, but it has really good chemical resistance. So then you can start to use it for some of the fluid or automotive transportation type fluid applications. We've seen this. So hot air, hot fluid, up to 150 C. You should be able to get to it.
150?
Yeah.
150 degrees, Celsius degrees.
Mm-hmm.
That's good. Polypropylene here, I think all the guys from that follow TalkPlast, it's the main plastic used in Brazil. So it's great to see that we have now another technology that can produce parts with polypropylene and have this kind of results, right? Because here with 3D printing, especially with powder, you can have a really complex geometry, really intricate parts, and you don't need to use a mold to produce, right? You produce this directly from the design, from the 3D model, and put in the printer. Yeah. So besides polyamide, nylon 11 that we have, and also the polypropylene, which is the other grade that's commonly used in the powder 3D printing.
We have the TPU material is going to be the other product that we really focus on. And there's a few different application areas that we've really found good results with this. So one is something like this, where we're looking at cushioning or like foam type applications. Mm-hmm. So traditionally with TPU, you order based on the hardness that you want, right? Like a Shore 30 or a Shore 50. We've found that we can accomplish a lot more with a single grade of TPU. So this is an 88A Shore hardness material, but then based on the actual structure that you use, you can achieve much different results. So very, very soft parts to very, very hard parts, depending on the structure and spacing that you use to build the parts out. So we've seen good application opportunities with the TPU in sportswear for cushioning and safety applications. We've seen good applications for footwear. Similar example there for insoles and midsoles on shoes. And we've also seen good applications for automotive comfort features, like some of the cushioning and comfort interior parts and in-cabin parts for the TPU. So. Yes,
please. I think that the guys that I seen our table today, they're looking directly to that bench that we have there. Mm-hmm. I think, Todd, if you can explain a little bit about this part, because it is made through powder 3D printed, so you use that powder, but you have two materials there and different hardness, even if it's the same material, right?
Yeah. So this is one area that we've really explored for seating applications. There's some really neat design things that you can start to think about when you look at an open foam like this structure style design. Because a lot of the cars around the globe are looking at heating and cooling in the seats, and most of the time they're using additional equipment to achieve that. With an open cell like this, you can actually use a more ventilating style system to heat and cool. You can also run wiring for different types of effects that maybe they're not doing in seating yet. So this opens up a lot of cool ideas for features that you can build into the seats. You see that there's 3 different colors here. You've got kind of a gray lattice on this side. This side you have more of a black shiny lattice, and then the middle parts are all blue. What this is showing is the different finishing options for the TPU. So it has, this is the raw finish straight out of the machine. This is if you use vapor smoothing, which is a pretty common additive post-processing technique using chemical vapor to actually smooth and polish the surfaces. And then the middle one is actually a coating product that we supply specifically designed for the TPU, made out of a similar chemistry. So it has really good adhesion as well as flexibility. So
when the part comes from the printer, it comes with a little roughness in the surface, right?
Yeah.
Even though if
velvety.
you work in the parameters, this roughness is part of the process.
Correct. Yeah. Really, really good parameters are going to give you a part that's a little bit, I like to think of it as sort of like a velvety feel.
Okay.
Kind of like a softer plush feel on the surface, but you can paint it, you can dye it, you can vapor smooth it. It's really accommodating to most of the common post-processing technologies for additive, unlike some of the other bases of TPU out there. So.
Perfect. I wish the guys that are following us right now could feel this, because it's like that's a big difference when you do this vapor smooth. The part doesn't even look like it came from the printer, right?
Yeah.
And the surface quality is one of the things that can differentiate the 3D printing technologies. Of course, the applications, the materials that can be used, the time to process, to print the part, but the quality of the surface is something that changes, because when you see a filament part that was made through a traditional machine equipment, you can see some of the layers, because it is deposited layer by layer, and you can see this roughness. It's the same for the powder, that you feel this roughness. But when you talk about the third technology, when you bring to the resin 3D printer with the photopolymers, this is something that we can have a really good quality surface, right, Mark?
Yeah,
this
correct.
is one of the main characteristics of the resin 3D printer.
Yeah, you can get as low as 25 micron layers for even your more cost-effective printers. Even a $500 frozen printer can print in a 25 micron layer, where you're not able to do that in some other technology. So you don't really see the layers like you see them in other styles of printers.
For the guys of the plastic industry, sometimes when I show a part made with this technology that Mark has, I think he has the mold that you talk about, but also that flexible part. Some people cannot differentiate it from the inject molded part due to the high quality of the surface. So please, Mark, if you could talk a little bit more about this process, because we understand here we got the plastic, we got the TPU, the polyamide, the polypropylene. When you talk about the filaments, it's the same. But for resins, it's a little bit different. The process is not the same for the plastic, right? Can you tell us more about the process and the applications with these materials?
Okay, so basically the process is you're using light as your energy source, and your printer is actually like a chemical reactor. You're converting it from liquid, and then you're crossing all the chain links to create your solid part that you see today. And with that technology, we can vary hardness and applications as well. We have something as soft as, this is like a 40 Chore, very soft, good for cushioning. And then you can go all the way up to our ceramic, and this is very, very hard, like 10,000 modulus. I don't know if you know what that means, but it means it's very, very hard.
And also the HDT, right?
Yeah.
It's quite impressive.
Yeah, the HDT is over 280 C for this one.
The HDT, that is kind of a measure of the highest temperature you can use the material with mechanical application. So it's not that the environment is in 280 degrees. It's that there's some pressure being applied to the material.
Yeah, so basically the test is like a 3-point, and you have a certain amount of weight on a bar, and it gives a certain amount by the time, over amount of time, and that's its HDT. So it's not like your filaments or your powders, where if you hit a certain temperature, this will melt.
Yep.
So this doesn't melt. It's it's solid, it's going to be solid.
This is one of the difference between the materials used in 3 technologies. While you are talking about powders, the SLS technology, or the filaments, the FFF technology, we are talking about thermoplastics. And while we are talking about the resins, we are discussing about thermosets.
Correct.
Yeah, so it's different process. That's why we use the UV light to make this part. And we spent a whole week here, and we visit a lot of partners, and we went to the FAMEC, the Mechanical Equipment Trade Show. And I think this was one of the most discussed topics, right?
Yeah, everybody was excited about the 3280, that's for sure.
Yeah, the whole time we were here, they were just calling our names like, hey, BASF, do you have the 3280, the 3280?
Yes.
We were impressed on how much momentum we're starting to get here with that 3280.
Yes, this is something that have been working, and we are still in the beginning of this product here. Since Additive and BASF bring this material, the plastic industry was able to use the 3D printer not only to do the prototype, not only to print a few parts, but also to make a real mold that can withstand the pressure, that can withstand the temperature, and be able to produce, to inject parts, like marca. He has here this mold, and the parts produced through injection mold. I think it was a PBT, 10% filled with 10% of glass fiber, so it is kind of abrasive material. But how many cycles, let's do from the beginning. How long does it take to produce one mold like this? And how many cycles does it withstand? Is it comparable to the metal mold? What are the main benefits when you use the printed mold comparison to other technology?
Well, obviously it's not going to last quite as long as a metal mold, but the real key here is the speed. So this mold printed, flat on a build plate can be printed in a matter of hours. Depending on your printer, it could be an hour, it could be 3 or 4 hours, but
it's nothing.
You have a mold, you can print your mold, clean it up, have it ready to go, and be injecting by the afternoon.
Wow. At the same day, imagine this: to concept the idea of your mold, to print it, and in the afternoon you are already making some parts through injection mold.
Yeah,
that's
pretty incredible.
That's the main advantage, because if we are comparing to a metal mold, to a steel mold or aluminum mold, maybe the durability will not be the same. But in the other hand, this kind of mold can take a few weeks to be produced, or months, and can be so high the cost that maybe sometimes if you have parts like this and you have low series production, the part won't be able to be made because the cost of the metal mold. Yes.
Yeah, exactly.
What are the main materials you have seen people injecting in that kind of mold?
So far there's been like the PP, the PO, the POM.
Okay.
Yeah, the glass fill, like you mentioned before. Lots.
All the plastic, basic.
Yeah,
since
all
it can withstand 280 degrees.
Yeah.
Most of the engineering plastics can be processed there.
Correct.
And Jaime, since you are looking more into the big picture of the Americas market, how you see this kind of product approaching the market?
I think it's a great product, and one of the things that I know about Latin America is very price sensitive. And when we're talking about a mold that's going to cost, I'll put it in dollars, anywhere between $15,000 to $25,000, when you can have a resin that's going to cost you, say, an average of $300 a kg.
Yeah.
That's right there. You made the point where you can make small production parts, and it's going to be cost effective. Yeah. Being out in the market where it's all about pricing, I don't see why we wouldn't want to give this a try. So I think there's huge potential, and I think the show we went to was the number one thing that said, wow, you know what, we've got something here that we need to have the market be more engaged with.
Yeah, I think this is the way that people can see that there's not only the filament 3D printed, the resin 3D printing can also be used for industrial application. we saw the flexible parts that Mark showed. These are all from the same material, right, Mark? You're just changing the structure.
Yeah, same like how Todd showed before. We're changing the same material. It can have totally different things. So just by changing the structure, it can go from, really soft to fairly rigid. Yeah. Depending on how you have your lattice structure made. It kind of makes it. You can do a lot with the same material. Yes. You don't need to keep changing materials.
That's perfect. So we can go from completely flexible to extremely hardness in the same printer. That's the same machine that can produce all of this. Mm-hmm. So just coming back to the mold, and I thank you, I appreciate the comments that Jaime made because here at this partnership Additiva BASF, we are putting our efforts for the plastic industry to look more into this application, because as you could see, this is a big deal here. This is a big deal, and not all the companies that produce parts through injection molding, they have the tooling in their factory. They need a third party. Now they can have the printer just beside the injection machine, produce their mold, and start production. I think this is one of the biggest things that additive manufacturing has made it here. And now, regarding the powders, this is for resins, one of the main topics. But for powders, what do you think from now on will be the most used applications or use case with BASF materials that you see as an opportunity for the Brazilian market?
So after the week, kind of observing the show, it looks like there's a really robust manufacturing industry in Brazil. Additive seems like it's just a little bit behind where it is in some of the other areas of the world. But I think based on the ecosystems that we're looking at trying to deploy here, slightly smaller machines, littler build volumes, I think there's a lot of opportunities for some of the rigid materials like the PA11CF specifically for like manufacturing aids, jigs and fixtures and tool trays and those types of things. I've seen a fair amount of automotive in the area, as well as communicated with folks at the show and at the meetings that we've had. And it sounds like there's some good opportunities for some possible automotive applications. So that could range the polypropylene, the TPU mainly, possibly some PA11 black or CF applications as well. So
tooling, automotive can both use this kind of material and be really successful, right?
Yeah. I do want to kind of add a couple points to what we've talked about so far. So one thing specifically with the molding part that I don't think we've really addressed so much is just like the logistics of having a tool, right? If you have a metal tool, typically you're going to mount that to use it and then demount it. And then you're going to have to store that, right? Which is going to take up space. And if you can do inserts and have a mold base, now you have one big thing you have to store and a lot of small things you have to store. So it's much less footprint, much less space, square footage that you have to think about for your business as well. If you can if we can set that up for deployment into a customer. For the TPU on both sides, right, we have a version of a part up in the front there, as well as a couple examples that we see here. These are actually for inspection. So
this is a powder 3D printer?
Okay. Yeah, we have a version of it that's straight from the machine in the white color. And then this is our TPU black that's been vapor smoothed again. So you can see it's got a shinier finish to it, more of a sealed surface. But in either case, either type of surface finish, this is actually a non-marring material. So if you're doing any measurements or inspections on paneling or a part that you've made that you have to be really conscious about scratches on the surface, these flexible materials are going to be really useful there as well. So that's why I think there's kind of a natural opportunity for some of the fixturing, for manufacturing. They're small parts, so you can make them in a smaller build platform.
Mm-hmm.
Materials ready-made to support, ready-made to apply to a support type application.
Oh, that's great. That's great. We think about the manufacturing methods, and we commonly are looking for the final products. But 3D printing can have a different approach that is to support during the process, not only the final part.
Mm-hmm.
Maybe the final part should be in mold injected because of the amount the parts, but there are some parts of the process that will need a specific design and a specific component that only the additive manufacturer could deliver. And now when you look at this table with rigid carbon fiber, with TPU, with ceramic, with metal,
Yes.
really important. So we've seen now that additive manufacturing can take it all, right?
Mm-hmm.
Can take it from the prototyping, but also from for the tooling and also for the final production. So it's kind of really flexible manufacturing method, right? And guys, I also would like to take this opportunity to ask. Okay, Brazil is a few steps behind in 3D printing. We discussed with a lot of customers, a lot of partners of Additiva and BASF this week. Mm-hmm. But I think what we have is the potential for this usage, right? This is something that you feel discussing with the guys here. Okay, the technology is not really mature today, but if they use these materials, they have the potential. The industry has, right?
Oh, for sure. Yeah, I feel like they're going to be where the States and Europe are, mm-hmm. but they're, I'm going to roughly guess like maybe where we were 5 years ago, 6 years ago.
Okay.
And they're just starting to get used to the technology, starting to trust it, kind of getting away from injection molding and creating parts, that you don't need 100,000 parts of.
Yes.
Mm-hmm. Yeah, I think it's kind of an interesting time period for both. I do agree with Mark. They're probably like 5 to 8 years mm-hmm. behind where some of the other regions are. But I think that's a really good opportunity for both sides, the 3D printing industry, as well as the uptake of 3D printing in the manufacturing industry. Because if we look at some of these other regions that are more mature, they didn't have quite as many options for equipment when they were starting to source things, and most of the equipment that's been sourced in those other regions is more closed up. So you don't have as many adjustments or as many opportunities to figure out what you need for your business. Really, you're figuring out how you can use 3D printing as it stands in your business, right? So if we look at how my team specifically interacts in the States, a lot more often, we're trying to replace an incumbent material, something that was put in place because that's what was available on the machine. They have a lot of years running it, and we have to convince them why it's the right choice to use the material that your part needs versus the thing they know that's going to print and only make a prototype. So with this industry being in this position where it's just starting to kind of bloom, and the machines being in a position where more machines are being created with an open architecture that allows the people, as they start to bring this process in-house or think about this process, to think about it more holistically for the type of parts they make or the business they do, versus how 3D printing is kind of a plug and play type of single solution. So
sure. Wow, amazing. And also this is, I agree with you, because the players of the additive manufacturing market here will agree, because when we talk about the difference between our market, our maturity to the other, we always talk about 5 to 10 years. So I think we are close to what they think too, and it's good because now we see where we can reach, right? If we have the potential, we have the industry, we have the people that are capable to use. We have the materials through Additiva and BASF here. So we have the machines. Now it's just a matter of people understanding that additive manufacturing is here. It can be used. It's not that, wow, that technology that's not to my reach. It's completely feasible, and in terms of difficulty of use and everything. I think I just going to the end of our episode. I'd like to ask you guys, what are the new materials you see that are coming here for both ends? I saw that Mark brought that part, right?
Yeah, the flame retardant.
Yes. Do you think this is one of the new fronts for additive manufacturing using resins?
Yeah, for sure. It's getting to the point where you can use it in automotive and rail and all these applications where you need the V0 rating to be able to use certain parts for connectors, different little like fuse box type, something where you need the V0 rating.
Okay, so this part has that UL 94 V0 certification for flame retardant material. And it's this one, it's a rigid part, right?
Yeah, it's a very rigid part, again, with a very high HDT.
High HDT.
Yeah.
Okay, so it can stand high loads, high temperature, and also if a fire starts, it won't be able to...
Yeah, self-extinguishing.
Wow. That's incredible. And if you add it to the complexity of geometry, you can reach through the resin 3D printer.
Correct. Yeah, you can. This works again. It's a very thin material that can be used again on any open source UV printer.
Okay. Thank you. That's a really good material. For sure, we'll discuss more about this because we have a strong electronic industry here that may be, and also the automotive that can use this. And in regarding the powders, what is the powder that you think it's or the thinking of BASF now on? It would be the sustainability, it would be something like this, or a new material?
Yeah, I think there's probably two main areas of focus, right? Expanding the engineering functional polymers, as well as sustainability and renewability topics. One example of a product we just launched is our PA11. It's a RPA11CF, which is a recycled base material with PA11 with a recycled with a recycled fiber in it. So we are trying to find ways that we can create a bigger impact for the renewability type topics. So that is going to continue to be a focus. I think that we'll continue to see more variations of the base polymers we have, likely with different fillers and different requirements, such as the burn ratings and skin contact type applications, as well as the possibility of one or two new base chemistries in the next period.
That's great, because a few weeks ago we had TalkPlast was present during the Bioplastics Brazil. We had a big congress just focused on biopolymers from renewable source and biodegradable and compostable. And I had the opportunity to be one of the speakers. And one of the things I discussed was really about the PA11. My idea was to say how the additive manufacturing can be both a performance technology, but also with the look into the sustainability, with the environmental impact. And the PA11, since it's bio-based, it also, in terms of performance, can compete with PA12, but being a clean polymer. And now you are telling me that you also can add recycled carbon fiber. So this is the ultimate of bio thing that we can have. I think that's great. That's great to see that BASF is looking further for the environment impact, right?
Yeah. If it is of interest, I know for the powders, we have almost all of our products have a life cycle analysis, what we call it. So an assessment of how much carbon is used during the manufacturing and processing to make a part. And then the life of the part, right? We've tried to put numbers to that so that if a company has a really strong requirement for making renewability a company function, that helps them understand their total impact. So we have those available for a lot of the materials on our portfolio, and they'll continue to flesh those out. So.
Wow, that's great. That's great. Great news. So we can expect for more things related to this field in the near future.
Yeah.
And for Jaime, I think my last question is, we discuss a lot of customers, partners here, new developments. You see the BASF brand through Additiva is being well spoken here. What do you think, how do you think about this, the importance of the BASF materials and this partnership with Additiva to promote this market here in Brazil?
Yeah, no, I think the past week we've seen a lot, and I'm really excited. I'm really thankful for you for being able to be that pioneer, for being able to go out to the market and teach customers about our materials. Because one of the things that is unique about us is look at all the materials that we have, right? That's one thing that's very unique in the market. And having such a strong partner like you to go after the market, have them show the parts, have them try out powders, have the resins. I think you're doing a very good job. And I think the market is going to get there. And I think one of the things that they need to realize is that maybe the powder is not a good application, but they can move to the resin. If the resin is not a good application, they can move to the filament under one big BASF umbrella, right? Mm-hmm. And I think the reliability and the market that BASF brings, it's great for the customers. It's great for you because you can say, hey, if the resin doesn't help, I've got something else at this. Just let me know what you're looking for. And I think that's going to be huge for this market. And I think, like I said before, Brazil has a huge potential here. And having somebody like yourself that's promoting the product, and also our resellers, I think they're doing a really good job. I was really impressed walking down the halls and just having our brand and our logos and having our parts being printed with our materials. That was awesome. I'm really excited, and I think, like I said, anything you guys need from us, we're always here to help and see how we can support you guys in this market.
Mm-hmm. That's great. That's great to hear, because also we also count so much on you. Mark is the guy that is mainly requesting when we discuss about this market of resins, and Todd also will be so much demanded through the powder application. So I think it's a good partnership. And when you see the big picture, the plastic industry needs this. The plastic industry needs the material, needs the people that help to develop the application, needs the TalkPlast to communicate this for all the market. Mm-hmm. So we are all part of the same process here. We need this to all together. Mm-hmm. So guys, with this, I think I'm heading to the end of this episode. It was incredible. Really appreciated your time, your effort to be here and to share about the materials, about the application, about your perspective on the Brazilian market. Additiva and TalkPlast are really happy to receive you. And if you want to leave one last message to the guys that are listening to us, please feel free.
Yeah, I'd say I tried to employ this at each of the places we stopped at and everybody that we talked to at the shows. But we look at it. Our business is to be agnostic of systems, so we want to try to create solutions, right? And we know, just like Additiva has been working, right? We know that there's not just a sell it and forget it mentality, right? We have to support the customer. We have to help troubleshoot. We have to help define parameters for specific part characteristics, and we look at that as a partnership. So it isn't just Additiva, working for us in this country. We're willing to put ourselves there to partner and help support the customer. So
perfect.
Yeah. Say what Todd basically is, reiterate, we want everybody to succeed. We don't want just us to succeed. We don't want just Bruno to succeed. We want to see all the customers succeed. We want everybody to succeed. That's the key.
We can be successful only if the customer is.
Exactly.
Right.
Exactly.
So we're here to help. We're not here to just give you a product and walk away. We want you to be successful.
Yeah.
And then lastly, just want to thank Bruno, Additiva, and just for hosting us all week. It's been a lot of fun.
Yeah, for sure. It was great.
Yeah, and I think one of the things that I want to do is make sure that customers are not afraid to, call Additiva, call our resellers. If there's a question that they can't help, they know who to contact. We've got, Mark that's really good. Mark is really good in resins. We got Todd's really good in powders, and they're always willing to go out of their way to help the customer. So if you run into an issue, I'm pretty sure we'll be able to handle it. We've got a lot of support. We've got a lot of resellers in the market, a lot of our distributor. So just reach out to us and don't be afraid to try out some of those materials.
Yeah.
We've got a lot to try.
Exactly.
We're the gateway to our whole organization. So if we don't know the answer, we have R&D teams, we have tech teams, we have design teams ready as part of our Forward AM brand to help support. So
That's great. That's great. And that's why BASF is such a reliable company, and it is not different in the 3D printing business. You guys are rocking it since the beginning, and for sure we will have together much more success here in Brazil. Pessoal, chegamos ao fim de mais um episódio do 3D Talk, hoje aqui com esses convidados especiais compartilhando tudo sobre os materiais da BASF e como é o mercado visto para as outras regiões também, né? Não só no Brasil. Agradeço a participação de todos. A TalkPlast, a Additiva e a BASF 3D estão juntas aí na promoção desse mercado de manufatura aditiva. Para quem quiser acompanhar, @Additiva 3D Printing, @BASF_Forward AM. Eu também, caso você queira acompanhar conteúdos sobre esses materiais, @OBruno3D, constantemente com alguns vídeos explicando essa tecnologia. Muito obrigado e até a próxima.